Okay, y'all. So, like I said, 5C deals with statistical tables and graph. All right, so first we're going to look at two types of data. So this will be data types and binning. So I'll tell you what we mean by binning. All right, so for our two data types, okay, so we got two main data types. We got what we call qualitative data. And qualitative data consists of values that can be placed into non-numerical categories. So this consists of values that can be placed into non-numerical categories. So y'all, let me give you some examples of qualitative. So that would be something like brand names of shoes. Okay, so the brand names of shoes, we can place them into non-numerical categories such as Nike, Reebok, Hoka, and so forth. So that's what we mean by qualitative data. The second is quantitative data. All right, so quantitative data, that actually represents counts or measurements. So we're getting numerical values for those, okay? So heights of students would be an example of something quantitative, like 5'3", 5'4", 5'5". Those are actually measurements, so they would be what we call quantitative data. Now up here it says binning. So what we mean by bins, a bin is a category. So these are categories that data can be placed into that cover a range of possible values. So, y'all, what do we mean by this? And this is usually quantitative data. So, let's put that right here. Quantitative data does this. So, quantitative data. So, an example would be like test scores on a test. If I was looking at test scores, I would maybe make my bin something like this: 90 to 100. I might go 80 to 89, 70 to 79, 60 to 69, and so forth, so that 90 to 100 would cover all my A scores. 80 to 89 would pretty much cover all my B scores, and so forth, okay? So that's what they mean by binning. Each of these is what we call a bin because it covers a range of numbers from 90 to 100, so about 10 scores. And there's about 10 scores per bin on this, okay? So that's what we mean when we talk about bins. All right, also next, let's get into what we call frequency tables. All right, so a basic frequency table has two columns. All right, so your first column lists all the categories of the data. Like on the example I did, my first column would be my bins I made for my A's, my B's, my C's, and so forth. All right, then you got a second column. The second column lists the frequency of each category. So what we mean by frequency is how many did I get for my A's? How many did I get for my B's and so forth? Okay, so we'll have our categories broke down and then how much or how many times each one of them occurs, okay? All right, y'all, then we got what we call relative frequency. So the relative frequency of any category is the fraction or percentage of the data values that fall in that category. So, of the data values that fall in that category. And y'all, I'll give you a formula for that. So, your relative frequency equals the frequency in that category divided by the total frequency. So if I was looking at my ABCD scale I made a while ago, relative frequency would be how many A's did I have? And then how many total tests did I have? Okay. So it's the frequency of each category divided by the total frequency, which is how many you actually had altogether. Okay. And then y'all finally a cumulative frequency of any category is the number of data values in that category and all preceding categories. So it's like you're sort of adding them as you go along for that cumulative frequency, okay? It's like adding the totals as you go through each of those categories. So y'all, I'm gonna let y'all catch up a second, and then we will look at an example of doing all of this, okay? All right, y'all. So for this example, I'm going to look at some test scores we're going to write down. So there's 20 test scores we're writing down. We got a 76, 80, 78, 76, 94, 75, 98, 77, 84, 88, 81, 72, 91, 72, 74, 86, 79, 88, 72, and 75. So I got a total of 20 scores, okay, from a 100-point exam. So what we're going to do, we're going to put our scores. So this is where we'll make our bins up. We'll find a frequency. We'll find our relative frequency. And then our cumulative frequency. Okay, so scores, frequency, relative frequency, cumulative frequency. Now, I'm going to make my bins for 95 to 99, 90 to 94, 85 to 89, 80 to 84, 75 to 79, 70 to 74. Because y'all, my lowest scores are in the 70s, so we're good. And then down here, we'll put our totals from the frequencies, relative frequencies, and our cumulative frequency. So let me pull up my chat, because what we want to do is start counting how many tests scores do I have that are between 95 and 99? So that'll give us the frequency for 95 to 99 on our test. So y'all, if we're going through here, let's see, we got a 98. So y'all see one, let's see, yeah, I just see one also, so good job. So that's a frequency of 1 for the first bin. How about 90 to 94? So how many of y'all getting 2 in that bin? All right, next we got 85 to 89. So y'all got 3 on that one. All right, y'all, let's keep going. 80 to 84. So let's see, 80, we got 80, 84, 81. So y'all getting 3 on that one? Yep, good job. All right, y'all, let's go. 75 to 79. Well, I'm getting quite a bit on that. Yeah, 7 on that one. Good job. And then y'all are last being 70 to 74. So 4 on that one. Now, we had 20 test scores. So when we add all these frequencies together, what do we get for that first column down here for the total? We got 1 plus 2 plus 3 is 6. So we're getting what, 20 on that? Good job. You know, that makes sense. Our total frequency has to be 20 because we had 20 tests. Now, to figure out the relative frequency, we're going to take the frequency and divide by the total, which was 20. So for this one, to find that, we would figure out what 1 divided by 20 equals. So y'all, if we punch that on our calculator, 1 divided by 20 is a 0.05. Good job. So we could say 0.05, or that's 5%. Remember, to turn a decimal into a percent, you just move the decimal right twice and add the percent. All right, so how about 2 divided by 20? That'll give us our second bin. So 0.1, good job. Or you could say 0.10 if you wanted to look like 2 digits. Either way, y'all. But move the decimal right twice. That gives us 10%. All right, y'all, looks like y'all got it. These next two have 3 on them. So they're going to have the same relative frequency. So we need to figure out 3 divided by 20. And that'll be for both of these. All right, so y'all getting a 0.15 or 15%. Good job. And then this one will be 0.15 or 15%. All right, y'all got a big one here. 7 divided by 20. So 0.35. Or Taylor, what do you got? 35%. Good job. All right, y'all. Finally, 4 divided by 20. And that should be yeah, that's our last one. So what are y'all getting on that? And 4 divided by 20. All right, 0.20 or 20%. Good job. So add all these percents up and tell us what we get. Or you can add all this up, 0.05 plus 0.1 plus 0.15. Add all them up. Either way, if you added all the decimals up, you should end up with a 1.00. Or in percent, Taylor, that's perfect, 100%. And that makes sense. If this is the percent that each one's happening, when you add them all up, you got to get 100%. Now, what I meant by the cumulative frequency is we take the frequency and bring that over here for the first one, which is a 1. Now, cumulative means we're going to add the next frequency and get that answer. So you take the next bin, add all the prior frequencies, remember. So 2 plus 1 gives us a cumulative frequency of 3 at that point. So y'all let me test y'all on this one. What's my next cumulative frequency going to be? 6, good job, because we had 3. The new frequency was 3, so that gave us 6. All right, y'all keep going. All right, 9, good job. So Trinity's on a roll tonight, right? All right, so now we got what, 9? We're going to add 7, give me 16. And y'all finally, for my last cumulative frequency, we get a 20. So y'all, the total on my cumulative frequencies was 20, which has to match the total frequency, right? So when you're done with your cumulative, it'll add up to what you got here on your frequency. Y'all, not bad. It's just setting up your bins, counting how many times they happen, and then you can figure a relative frequency and then your cumulative. All right, y'all, good job. So now we will look at bar and pie graphs. All right, y'all. So when I talk about a bar chart, so a bar chart shows each category with a bar whose length corresponds to the frequency. Or the relative frequency. Okay, so like on the one we just did, from my bin from 95 to 99, my bar would have been only 1 unit high. But that second category, 90 to 94, had 3, so that one would be like 3 units high. Okay, so the height of the bar sort of represents how many times they occur. All right, y'all, then the pie charts are used primarily for relative frequencies. And that's because the total pi must always represent the total relative frequency of, well, y'all will go when we looked on here, our relative frequencies, our total was 100%. So your pi has to cover that whole 100%, okay? Now on the pie charts, the size of each wedge is proportional to the relative frequency of the category it represents. Okay, so if you have something that's 50%, then half that pie is going to be done, right? So let's look at a pie and figure out what they're talking about. So if I was to half it, each half would be 50%. If you take a half and half it, each of these pieces would be 25%. Okay? So when you're done with your pie, all the pieces have to add up to 100%. Okay? So this one here would be what? 25% also. Now, some might be broke down into 30% something, 40% something, 20%, but the size of them pieces of pie have to be proportional to how large those amounts are, okay? Alrighty, y'all, and it's also when you're dealing with charts, there's some important things you want to do with a chart. So let's look at some of the important labels for our graphs. Oh, the first thing, you want a title or a caption. So explain what's being shown. And then, if possible, list the source for the data, okay? So let us know what we're looking at, and then, if possible, give me the source. Second thing, you want a vertical scale and title. So you want to have numbers along your axes that clearly indicate the scale, okay? So you want your numbers to line up with the little tick marks on the graphs. And then also put a label that describes the variable. Like if I was doing test scores, my vertical scale would be maybe 70, 75, 80, 85, 90, 95, and so forth. Okay, each tick mark would be about 5 places on my scores. And then my title could say something like test grades or something, okay? All right. You want a horizontal scale that goes straight across. So vertical is up and down scale. Horizontal would be straight across. And title All right, so your categories would be listed along this horizontal axis. You don't have to use tick marks for those. You just have your data separated, okay? And then you want to have a label that describes that data. All right, so a legend, if you have multiple data sets that are displayed on a graph, you can use a legend to identify the individual data sets. Like on my pie chart, I might have a legend over here, and I might have one piece colored orange. Well, the orange might mean a certain grade, and whatever's shaded blue, blue might mean a different range, okay? So you're sort of using color legend to represent your data. Oh, yeah, also, we'll talk about another few types of charts, and then we'll look at that homework, okay? All right, so other types of charts are what we call histograms and line charts. All right, so first the histogram. It's a bar graph for quantitative data. So remember, quantitative deals with measurements and stuff. So a bar graph is for quantitative data categories. So on a histogram, the bars have a natural order and the bar width have a specific meaning. We got a line chart. So on a line chart, it shows the data value for each category as a dot. And then the dots are connected with lines. So y'all, let me show you some examples of those. So this would be a histogram, and then this one is a line chart. So the hint is the width of these bars for the between 70 and 75. The height of this bar is 4, so that would tell me that I had 4 scores in that range. This height of this one is 7, so that tells me 7 scores were between 75 and 80, and so forth, okay? So this is the example we did a while ago. We had these two both had 3, remember? So their both height is 3. From 1995, we had 2. And then from 95 to 99, actually, we had 1. Okay. Now, the line chart does the same thing, but what it does, this score between 70 and 75, they put a dot in between 70 and 75 at how many it happened. So this dot's at 4, so that means 4 tests were between 70 and 75. This dot is at 7, and it's above the 75 to 80. So they put the dot in between the two numbers at the height it occurred. Okay? So remember, these two were the same at 3 each. So between 80 and 85, 85 and 90, both of them were 3. Then we had 2, 1, and down to nothing. So y'all, that's sort of the difference between your histogram and your line charts. And y'all, so what we're going to do now, we're going to go play with this homework. So y'all give me a second and let me get MathLab pulled up. And I think this one had like 10 questions. All right, y'all trying to get my MathLab to kick in. All right, y'all, finally, I got it ready. So let me share this screen. All right, so we'll start out with our qualitative and quantitative, okay? So, what is the distinction between qualitative data and quantitative data? So remember, we said that qualitative data describe your categories like colors and stuff like that, shoe brands. And our quantitative data was our counts and measures. But now you got to look at these reasons. This one says brand names of shoes and eye colors are examples of qualitative. Heights of students and quiz scores are examples of quantitative. So, that sounds pretty good. Let's look at B. They're saying quantitative was categories, which is wrong, and qualitative was the counts or measures. C says qualitative describe categories, which is right. Quantitative represents counts. But then it says brand names of shoes in a survey and eye colors are quantitative. Well, that's wrong because those are qualitative. So they're mixing the reasons up on that one, okay? And then the last one's wrong because it says quantitative describes categories, which is wrong. Quantitative was our counts or measures. So y'all, the only one that we can choose on that and has to be A, okay? All right, then you would check that answer. All right, so we want to know if this makes sense. The relative frequency of B grades in our class was 0.3. Well, that's possible, right? You can have 3 out of 10, which would give you that. 6 out of 20 would give you a 0.3. So let's look. A says it makes sense. There's 20 people. If 4 had B's and 2 had A's, then the frequency of B grades was 4 plus 2 over 20. Well, that's wrong, because if you're looking at the relative frequency of B grades, you wouldn't even add the A grades in that, okay? So B says it don't make sense. C said it didn't make sense. So let's look at D. It makes sense, they said. If there's 20 people in the class, if 6 got B's, well, that's correct. Then the frequency would be 6 over 20, which would give you 0.3. So y'all, we would say D on that one, okay? Remember, the relative frequencies can be anything as long as it's below 1, okay? Anything over 1 is not possible. So y'all, is this one possible? Can you have a cumulative frequency? Remember, cumulative was when you added them all up. So the cumulative frequency of C grades in our class of 32 students was 45. So is it possible for your cumulative frequency to be higher than your total students?
No.
Right, there's no way that can happen. So it does not make sense. So now we got to figure out C or D. Um, Now we can't say more students should have gotten B grades. So Taylor, I'm going to go with what you say because the frequency cannot be higher than the total. Good job. So y'all, you notice they'll usually give you 2 that make sense, 2 that don't make sense, but you got to sort of look at that reasoning on those to figure out what y'all want, okay? Um, so this one, same thing, makes sense or does not make sense. Your pie chart must be wrong because when I added the percentages of your wedges, they totaled 124%. So y'all, can a pie chart have over 100% even? Remember, we said on our pie chart that had to total up to 100%. So they're saying it was 124. So that makes sense that they're wrong. So let's look at one that says it's wrong. So we want B or D on this one. I mean, no, we want to say A or C. My bad. So A, that sounds good, right? Because remember, the total pi, the total relative frequency has to be 100%, okay? And y'all, I don't even know what they're doing down here. They're talking about 360. They're talking about how many degrees is in a circle. Whew, we don't care about that. We're caring about that 100%. Good job. All right, y'all, so look here. We got, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. We got 24 grades here, okay? 24 total grades. How many A's do I got? So that'll be the frequency for the A's. What are y'all getting on those? So let's see, 1, 2, 3, 4, 5. Let's see, 1, 2. Okay, you got it. 5, 5. There you go. So 5 on that. Now, give me the relative frequency. That'll be 5 divided by 24. See what y'all get on that. And y'all, it's saying round it to the nearest tenth. So if you divide 5 by 24, you get 0.20. Let's multiply that by, move them decimals right twice. You get 20. Now we got to go one more digit, Taylor, because if you notice right here, it says round it to the nearest tenth. So you need to give me a 20 point what? So y'all, when I divided it out, I got 0.2083333. When I moved the decimal right, I had 20.8333. So since 8 was in the tenths and it had a 3 after it, I kept it as an 8. All right, let's see what y'all put here. What is the cumulative frequency for this first row? I remember this is how many was on that row. How many is there altogether? For your first row, your cumulative frequency has to equal the frequency that that row had. Remember, this is the one where we're going to add them all together, Trinity. And when we're done with the cumulative frequency, it'll equal that 24. All right, here we go, y'all. All right, how many B's do we got? All right, y'all got 6 on that. All righty, let's do 6 divided by 24. So 0.25, if we move that to the right, we get what, a 25? But y'all notice, you might have to put the 0.0. I'm going to check it both ways for y'all, but we'll check it in a second. What's the cumulative frequency? 11, good job. So y'all on that, and then they want a 0.0 then. So let's put that as a 25.0. So Trinity, put a 0.0 and let's see what you get. All right, so y'all think if you get an even percent, you're going to have to add a 0.0 after it so that it's in the tenths, okay? All right, y'all, how about, what do we got? C next. So 1, 2, 3, 4. All right, you got an 8 on that. That sounds good. All righty. 8 divided by 24. All right, y'all, so y'all should be getting what is 0.33333333, which I'm going to move the decimal right and make that a 33.3. All right, I need the next cumulative. So, Taylor, what do you got? 19? Because 11 plus the 8 gives us 19. All right, we'll check that. All right, y'all, D, how many D's? 4, so 4 there. All right, so do 4 divided by 24. So I'm getting a 0.1666. So if we move that 2 over, you get a 16.666, which we're going to make a 16.7. Okay, so after you move it over, that 6 gets rounded up because it has another 6 after it, okay? Trinity, you probably got different values than we do. So let me get through this and then I'll see what might be messing yours up. All right, y'all, cumulative frequency is 23. All right, we'll check that answer. All right, how many F's? So, y'all, we just got one F, right? All right, so 1 divided by 24 gives me 0.04166. If I move that decimal right, I get a 4 point. So my 1 has a 6 after it, so that's going to be a 4.2. And y'all, finally, the final cumulative frequency is, what y'all got? 24. All right, y'all, so what's the total frequency? Well, we know what it better be, right? How many tests did we have? So our total should be 24. Good job. And then it's showing that our percents added up to 100. And then your cumulative frequency total was also 24. So remember, on the totals, the frequency, cumulative frequency will be the same. Alrighty, so they want to know if this is qualitative or quantitative. The flavors of ice cream sold at a delicatessen. Well, y'all, you can't count them and you can't measure them. Flavors would be qualitative. And then see, it says because flavors are non-numerical categories. So D don't really make sense. They're saying it's qualitative um, because how good the flavors are is subjective. So that's an opinion. So we're just looking at the flavors that are sold. Okay. We don't care who likes them and all that. So remember, quantitative, you're counting stuff or measuring. Qualitative is just categories. So, what are y'all putting on this one? The annual salaries of WNBA basketball players. Is it quantitative or qualitative? And then, which reason you picking? A, B, C, or D? All right, so y'all, those are quantitative because salaries are numerical. All right, so I finally got one popped up. A, that's perfect, right? Because it's quantitative because the salaries are numerical categories. Good job. All right, y'all, the same thing we're doing on this one. Same thing we did a while ago. So I need to know how many of these data are between 91 and 99. So y'all, I'm getting 6. Are y'all? Let's see, we got 98, 92, 97, 96, 98, 94. So I'm getting 6, right? There we go. All right. How many total we got? 2, 4, 6, 8, 10, 12, 14, 16. We got 20 altogether. So take that 6 and divide by 20. And remember, we got to round it to the nearest tenth. So y'all, I'm getting point 0.3. If I move it right, I get 30. But I got to add a point 0 on that because they want us to round it to the nearest tenth. Okay, so y'all got to add a period on those, and whatever's next, you got to put that digit, okay? All right, cumulative frequency. Well, y'all, the total frequency we have so far is 6. Good job. All right, y'all, 82 to 90. Y'all, I think I'm getting 3. Are y'all? 87, 85, 82. So that looks like 3 of them. All righty. What is 3 divided by 20? That's a 0.15. But remember, you're going to move the decimal right, make that a 15. But y'all, since it's 15 even, we still got to add a point 0 because this thing wants me to round them to the nearest tenth. Okay? All right, y'all. Cumulative frequency at this point is what? All right, 9. So let's put 9 in. All right, y'all. 73 to 81. So there's 1, 2, 3, 4, it looks like. All right, give me 4 divided by 20. So 20.0. And then cumulative frequency for the third row. 13. There we go. Whoops, did I count wrong? Y'all, let me count again. 73 to 81. 1, 2, 3. Y'all, that is 4, right? All right, so let me see what's happening on that. I'm just gonna, let me just put 20 and see if that's what it wants. Oh yeah, I'm gonna have to just hit the. Oh, they're saying there was five there, y'all. I don't see five. Are y'all seeing five? 73 to 81. One, two, three, four. Y'all, am I missing something here? Are y'all seeing five between 73 and 81? 76, 74, 76. Oh my God, 80. I didn't, yeah, I passed right over that 80. My bad. So that should have been 5, 25, and 14. Josh, good job. I was sure passing over that 80, not even seeing it. All right, so maybe we can count 64 to 72 correctly. Let's try that. Actually, you should have got me on that one because I sure was passing that over. All right, 64 to 72. So one, two, three, four, five, six. Are we getting six? I hope. All right, well, we know what six is because we had that up here on the 91 to 99. So six will be 30% again. So cumulative frequency. Go from the 14 to 20. There you go. All right, y'all. So maybe we had better eyes that time. All righty. All right, so the totals. Total frequency, well, that has to be all the test. So that would be what, 20? And then the total for our cumulative frequency was also 20. So those will add up and be the same on those. We all sorry about that 80 there. All right, so this one, it sort of gets you familiar with these bar charts. Um, so this is five of the most populous countries on this little table at the top, and they want to make a bar graph for the data. So the categories are going to be United States, Brazil, Nigeria, Bangladesh, and Philippines. And it looks like they're going in order, okay? So that means the United States has to be the highest bar no matter what, because it's got 331 million. And then Philippines is going to be the smallest bar because it's only got 110. So look at the little legends they're giving us. So the A, United States is red. So see how that red one's the tallest? Philippines is black, which was our smallest. And let's see, next to the United States should be Brazil, which is yellow. Now let's look at B. They got Brazil as the tallest, so we know B's wrong. C has United States as the tallest. And then looks like Brazil and Nigeria are pretty close. Bangladesh and Philippines. And then y'all, what do we got on the bottom one? They got Brazil as the tallest. So, and notice how they want the bars in descending order. So what they mean by descending order, they want the largest and then go down to the smallest from left to right. So y'all, A is going in ascending order. They're getting larger. We want the one which is correct, but they're going downhill. So Taylor, what do you got? C, and that's it, right? They're going from the largest down to the smallest. Now, Ashley, yours was right. Technically, there were two correct ones, but A was not in descending order. So you sort of got to look at everything they're putting there on us, okay? All righty, so construct a pie chart for the percentages of mothers aged 40 to 44 in a certain country with various numbers of children. So, y'all, this first one says for one child is 18%, two child is 48%, three is 24%, and four children is 10. But all them pies are the equal size. Each one of them is just a fourth of the pie. So it's not proportional like it needs to be. All right, let's look at B. B, 48% for one, 18%, 3% was 24, and then yellow was for four or more. So that one looks like it's got the right size pies, right? 48% is almost half, which is what they're giving us. All right, y'all, let's look at C and see what's wrong with it. So C has the orange 48% for two. And now remember, what we got to look at is over here, it's telling us that one should be 18%. Well, y'all, this one has 18% for one, that's blue, right? Two is 48%, that's orange. Look how much of that orange there is, that's 48. Three should be 24, green, and then four would be the 10. So the difference between B and C, B, their 48% was for one kid, but that don't match the little table up here, okay? So let's see this one. Blue, 18%. Two was 48%. Three, so they got this part wrong. The three should be yellow. I mean, this should be yellow where the green is and green where the yellow is. Okay, so you got to look at all the pieces and make sure they're big enough to represent that area. Okay, so technically the only one we can go with, what do you got? C, Taylor, good job. Honey, also that was that 5C. And the trick is look at their answer blanks and see like are they wanting you to go one decimal point on those, okay? So if you get something and it says go one decimal point and you get 30%, you got to add a point oh after that, okay? Other decimals, round them off to one decimal point after that decimal. Honey, also, I'm ready for any questions y'all got.
I have a question over the family monthly budget project.
Okay.
Did we go over what the cost was for the emergency and the Christmas and dental? If so, I missed it.
So y'all let me pull my I'm gonna pull up something real quick. Okay, now for which one was you asking?
Do we put the budget in for the emergency, the family savings, basically?
Okay, so I'm gonna pull this on out. I don't remember if they gave me values. I think in the thing it was saying they wanted to do savings and stuff. Um, but based on the data, I don't think there was any values at the moment to put into that.
Okay.
So that would be maybe something you could do if you want to let them do that kind of stuff. You can do that and maybe take something away from something else. Or if they want to do some savings, maybe the wife can work a job or part time or something to help with the income and all that stuff. Okay.
Okay, gotcha.
So yeah, that's just optional if you want to let them do that. Um, when you start, you should be in the red like $293 after you put all their data in. Okay.
Okay.
So yeah, play with that, and then each night we can keep working on these and get y'all fixed on any questions and all that. All right, y'all. Any more questions? So Ashley, was yours at negative 293?
Yeah, it is.
Okay. Okay, so you're perfect.
Okay.
So you just got to add and take away and what you think. Like on the phones, do they need a landline phone and a cell phone? So that stuff y'all might take one of them away from them. Should they be given to charity if they're in the red? Right? The wife can work maybe part time. I mean, just y'all fix them ever how y'all think. Okay? Y'all just want to make sure they're at zero or in the black instead of being in the red. Okay?
Okay, sounds good.
All righty. All right, y'all. Any more questions? And then, if y'all want,